Welcome to the very first video of our robotics series. So this is a brand new series and this is the first video of our robotic series. So today we are starting from the beginning. So firstly we are going to talk about what exactly is a robot. So we'll look at how robots are defined, what they are made of, and the different types and the classification used in modern robotics. Okay, what is a robot? At a basic level, a robot is a machine that can sense, think, and act. It receives information from the environment through its sensors, process that information using a controller, and then respond using actuators like motors and servos. So this sense, think, act cycle. So sensing things, thinking and acting according to those thoughts. So this cycle is what separates robots from ordinary machines. Okay. According to the ISO 8373 standard, a robot is an actuated mechanism that is programmable and capable of moving to perform tasks. So this definition emphasizes two things. The first one is a robot doesn't just sit still, it interacts with the physical world. And the second thing, it must be programmable, meaning we can change its behavior. So why do we even need a robot? So robots can perform repetitive and dangerous tasks that humans shouldn't or don't want to do. So they work with high accuracy, they don't get tired, and they help increase productivity. From manufacturing to surgery to space exploration, robots help us to do things that are too difficult, too risky, or too precise for humans. So that is why robots are very important. That is why we need robots. So major components of robots. Major component of a robot. So every robot is built using few key components. The first thing is the mechanical structure, which gives the robots its shape. So the next thing is the sensors. So sensors which allows robot to observe the environment. Then we have actuators like motors which allow movements, and control system is the basically brain of the robot, and all the things are connected to this brain. And finally the power system keeps everything running by supplying power. So together these all components allow a robot to operate intelligently. So the word intelligent is very important when considering a robot. Okay, how robots are classified? Okay, so now that we know what a robot is, okay, now we can classify those robots. So there's no single way to classify categorize all robots. So engineers typically classify robots based on several factors like the movements, how they are built, what tasks they perform, and how autonomous they are. So let's go through each category one by one. Okay, the first one is the classification by mobility. So what is mobility? Mobility is the ability to movements. So one of the most common ways to classify robot is the mobility. In other words, how the robot moves. Some robots are stationary, like industrial robots. They are stationary robots like CNC machines. Like others are mobile like wheeled or leg robots. We also have aerial robots, that's drones, and underwater robots that operate beneath the ocean surface. Each mobility type suits different environment and task. Okay, the other one is the wheeled robot. So wheeled robots are the most common type of robot that we can see. They are simple, energy efficient, and easy to control. So you will find configurations like different drive robots or wheel robots like 4-wheel or 6-wheel platforms likewise. So these robots are perfect for indoor navigation as well as the outdoor and flat terrifying movements. So the other one is the legs robot. Leg robot is on the other hand, are designed to mimic animals or humans. So they can navigate rough terrain much better than wheeled robots. And we have bipeds like humanoid robots, and quadrupeds like robotic dogs, and hexaped like with 6 legs. And they are more mechanical complex but incredibly versatile robotic platforms. So the other one is the aerial robots. So aerial robots commonly known as drones and operate in the air. So this includes like multi-rotor drones, the ones we usually see, as well as fixed wing drones and hybrid VTOL designs. Like they are widely used in photography, mapping, agriculture, delivery, and surveillance systems. Next, we have the underwater robots. So this includes ROV, that remotely operated vehicles, which controlled by an operator, and the other type is the AUV, autonomous underwater vehicles, so which can explore ocean with little or no human input. So they are used in marine research and pipeline inspection and deep sea explorations. So the other thing is the classification of mechanical structure. So this is another way to classify robots by their mechanical structure, basically how they are built. Some structures are designed for speed, and others are for precision, and others are for like human-like flexibility. So let's look at the main categories. So the first thing is the articulated robots, are the robotic arms you see in the factories. So there are multiple rotary joints, often 6, which allow them to move with great flexibility. These robots excel in tasks like welding, painting, and assembly. So the next is the SCARA robots. SCARA robots are selective compliance assembly robots arms. These robots are designed for high speed, high precision operations like pick and place. Their unique structure allows them to move quickly in horizontal plane. So the next one is the Cartesian robot. Cartesian robots operate in straight line along the XYZ axis. This simple rigid design makes them ideal for CNC machines, 3D printing, and automated manufacturing. Okay, Delta robots. Delta robots use a parallel linkage system. They are extremely fast and are commonly used in packaging and food industry for rapid sorting and picking. So you can easily recognize them by their spider-like appearance. So this is very accurate, high precision robot type. And the human robots, you always seen in different pictures. The humanoid robots are designed to reassemble the human body, both appearance and movements. So they are often used in research, assistant, and social interaction. So example like NA or ACA, Asimo. So other research humanoids. So okay, classification by application. So robots are also classified by their application, that is what job they perform. So industrial robots focus on manufacturing. Service robots help people in daily tasks, and medical robots assist doctors in surgery or rehabilitation. So agriculture robots supports farming, and military robots help in the defense and security. When considering this robots classification by autonomous, so proliferated robots are fully controlled by human, for example bomb disposal robot. Likewise, so the other one is the semi-autonomous robots, share control between the human and the machine. Drones with obstacle avoidance are the good example for this type of robots. And the fully autonomous robots, so they can decide their own tasks like self-driving cars and etc. Okay, in summary, a robot is a programmable machine capable of sensing, thinking, and acting. Robots can classify it into many ways like mobility, mechanical structure, application, or autonomy. So robotic is a incredibly a very vast field, and understanding these basics is a foundation for everything. So we'll explore in this series.